Alright, so this video is going to be on properties of logarithms. And properties of logarithms come in handy in uh, multiple settings, especially when it comes to solving equations and trying to make things simpler. And so we'll use those later on, but you kind of got to know the properties of logarithms. So let me give you three of them. They are called the product property, is what I call the first one, the product property. And so when you see the logarithm of any base, and there's two things being multiplied on the inside, x times y, or 3 or 4 or 5, but you can expand them and break them up to become the log base b of x plus the log base b of y. And so you can have yourself two logarithms instead of one expanded out using addition. The second one is the quotient property, and that is going to be log base b, and then instead of x times y, it'd be x divided by y, and it'd equal log base b of x minus log base b of y. These properties are definitely related to properties of exponents. Normally in properties of exponents, when you multiply like bases, you add the exponents, and so you see the idea where when you multiply x and y together inside a logarithm, you use addition to break them up, and when you divide in like bases, you subtract exponents. So the same idea is true when you divide within a logarithm. We're going to use subtraction to break it up. And it's all tied back to the idea of the inverse function, which is going to be an exponential. And third and finally is one that comes from the first, but it's the power property. And it looks like this: log base b of x to the n, and it equals n. You take the exponent and you put it in front and multiply it by log base b of x. Alright, and so let's kind of see them in action. The first one, if you wanted to say log of 2x, could be expanded by doing log of 2 plus log of x, and this is called expanding. And another one, let's say, would be the log or natural log of 2/3. You could expand the natural log of 2/3 to be the natural log of 2 minus the natural log of 3. There's another way to do this, and instead of starting with one logarithm and getting multiple logarithms, you could actually do what's called condensing, and essentially you just go backwards. And so take, for example, 2 log of x plus 2 log of y, right? With the power property, it says that the number in front of the logarithm is actually related to the exponent. So you take that 2 and make it the exponent, and take that 2 and make it the exponent. And so you would have log of x squared plus log of y squared, and the product property says addition relates to multiplication, so I'm going to multiply x squared and y squared and have just one logarithm, so log of x squared y squared inside one logarithm, just like that. Alright, so that's kind of the idea behind logarithms and what we do with them. So let's try a couple more interesting ones of expanding and condensing. So we'll start with expanding. So the idea of expanding is you're going to take the one logarithm and you're going to use the properties and make multiple logarithms. So let's take, for example, this one, number 1. Log base 6 of a times b to the third. So the first thing we're going to do is we're probably going to separate the a and the b to the third, because if you think about it, the a and the b are being multiplied, and this power of 3 right here is not on the a and the b, it's just on the b. So the best idea here is to break it up using the product property. So the log base 6 of the first thing being multiplied, so a, plus, because it's multiplication, log base 6 of b to the third. Then we don't leave exponents where they are, but since exponents now can come in front, we'll finish the problem using the power property. So log base b of a plus 3 times log base b of b. Okay? And that would be fully expanded out. Oh, that's not a b, that's a 6. Look at me go. Can't even read my handwriting. Log base 6, log base 6, base 6, and base 6, you know? Look at that. There we go. We all make mistakes. So it would be log base 6 of a plus 3 times log base 6 of b. Next one, let's try something that could come up here quite often, is radicals and those types of things. So the natural log, and in the natural log you'll have the square root of x over 2y. And so square root of x over 2y. And so first thing we're going to do is we're going to break it up because we have division happening inside the logarithm. That's what that bar means. So we will use subtraction. So the natural log of the square root of x minus the natural log of 2y. Couple of things we want to say about this problem is you want to remember that the square root can be written as a power, so ln of x to the 1/2, because that should give us some insight into what to do next. Right? We can use the power property to make this guy go in front. The other thing is that one thing I want you to see is that 2 times x is taking place. So you actually can expand the 2x. And so to finish this problem, we're going to say 1/2 times ln of x minus, and then I'm going to use parentheses to expand the rest. If you expand behind a subtraction symbol, you should use parentheses. So the ln of 2 plus the ln natural log of x. And then close parentheses. If you would like to distribute the negative, you can, but you can leave it that way. So your answer would be as follows. All right, let's take a look at one condensing problem, and then we should be good. So condensing, as I said on that first part, is going backwards. So an example of condensing, right, is 5 log base 7 of x minus log base 7 of y. And so usually the first thing I do is I take all coefficients and I turn them back into exponents. And so we would have log base 7 of x to the 5th minus log base 7 of y. So all exponents become, or all coefficients become exponents. And then I take a look at what's happening and I see subtraction, and so I'm going to use division. So remember, you should end up with just one logarithm. Don't divide the logs. You want to divide what's inside the logarithm. So x to the 5th divided by y. And that would be your answer. If we take a look at this last example I'll do, just so that you can kind of see it one more time. Call this number 1, number 2. We've got log of c plus log of a over 2 plus log of b over 2. The reason this problem is interesting to me is because you have to deal with this divided by 2, and you have to think of it in terms of plus multiplying by 1/2. Right? What's the same thing as dividing by 2? It'd be multiplying by 1/2 is the same. So plus 1/2 log base b. Now we have coefficients. We could turn them into exponents. And so we'll have log of c plus 1, or excuse me, log of a to the 1/2 plus log of b to the 1/2. And we're going to multiply all that together. And you should end up with, after simplifying a handful of things, making the a square root and square root of a and the square root of b, we should end with the log inside one logarithm c times the square root of a times b. And that would be what you have. So c times the square root of a times b. All right, have a great day.